This is Algebra 2, Lesson 8.1, Basic Probability. So hopefully this lesson is more of a review than anything new. Theoretical probability is, all probability is given in a ratio or a percent or a decimal or a fraction. It's the likelihood or the chance that something's going to happen. And so the theoretical probability is the number of ways to get a specific outcome over all the possible outcomes. Experimental probability means you're doing some sort of experiment or trials, and your ratio of the observations of a specific event over all of the trials would be what experimental probability is. So remember, theoretically means if I look at all the possibilities, all the outcomes. Experimental probability means I'm going to try it. I'm going to do an experiment, and I'm going to see what I get. Before I keep going, there is a handout that is available if you need it for dice sums and for playing cards if you're not really very familiar with what a standard deck of cards looks like. We will be using this sum table on this first example. It says, find the theoretical probability, assuming you roll a pair of standard dice, and letter A says the probability of sum of 6. So if I go back to my handout and I add a 1 and a 1, I get a 2, and a 1 and a 2 I get a 3, and a 3 and a 1 I get a 4, and a 5, and a 6, and a 7, and a 1 and a 2 is a 3, and we can kind of see this pattern. It just kind of builds on itself. I'm not even going to finish filling out the whole thing, but I can see right where all of my 6s are going to be. And to answer the first question, what's the probability of rolling a sum of 6? I have 1, 2, 3, 4, 5 out of, there are 36 altogether, 6 by 6, 36. 5 out of 36 would be my answer for the first question. Now I said that a probability can be a fraction or a decimal or a percent. If you would like to leave the answer 5 out of 36, you can. That's the right answer. If we wanted to take it a step further, I know that is the same as 0.138 repeating. We could even take it a step further and say 13.8%. But if you wanted to leave it at 5/36, that's fine. My next example says, what's the probability of getting a sum less than 5? Well, I'm going to go back to my sum table, and a sum of less than 5 would show up right here. 2, 3, 4, all less than 5. So I have 1, 2, 3, 4, 5, 6 entries on my table that are less than 5 out of the 36 entries altogether. So again, I will accept 6 out of 36. You can reduce that fraction. You can switch it to a decimal. You can even switch it to a percent. Big B. Callie rolled a pair of dice 300 times. She got a sum of 6 48 times. What is the experimental probability of rolling a 6? Since she saw it 48 times, out of the 300 times, our answer is 48 out of 300. And just to see how that compares to the theoretical probability, 48 out of 300 is about 16%. Whereas the theoretical probability, we already calculated right here, was 13.8%, so her experimental probability was slightly higher than the theoretical probability. The last example says, if you choose one random card from a standard deck of playing cards, what is the probability that the card you choose is a heart? Here's a standard deck of playing cards showing me all 52 cards. I have 13 cards in each column. 4 columns, 4 by 13, 52 cards altogether. The question asked specifically about hearts. Well, here are my hearts, and there are 13 of them out of the 52. We can reduce that to 1/4. We can switch that to a decimal. We can switch that to a percent, or we can just leave it a fraction. These are all correct answers. That's it for the notes. Good luck on the exercises. Let me know if you have any questions.